Hello all. In today's lecture we are going to see Turing machine example. Before that we will see what about the tuples. Turing machine, how many tuples we have? We'll first write and then calculate Q, number of state, input, TOC, the symbol of input, delta, Q0, blank symbol and final state. 1, 2, 3, 4, 5, 6, 7. How many tuples we have in Turing machine? Tuples we have 7. Which are those? I will state once again. Q, number of state, input symbol, TOC, the input symbol of tape. Keep in mind input symbol of tape. The transition, starting state, B stands for blank symbol, F stands for final state. Yes, have you understood? Tuples, how many tuples for Turing machine? 7 tuples. Q, states, input symbol, TOC, input symbol of tape, delta, the transition function, Q0, starting state, B, blank symbol, and capital F for the final state. Here we will see a problem. Let's take one example, that question, that the language equal to a to the power n b to the power 1 power n solve for Turing machine. Yes, we'll see one basic example that we have seen this example since our very first concept, that whether it's a regular or not. After that we have seen in push down automata whether it's a context free grammar or not. After that we are going to see whether it's a decidable or not decidable. This is very basic example which we are going to see with the Turing machine. Now while solving the Turing machine, first we have to define logic. What we have to do? Define logic. That means we know that in Turing machine I will have tape. In that tape there is blank symbol. After that there may be anything, that will be an array, and there will be a blank symbol. That means in between you can take any length of string, but starting and ending must be with blank. It may be a single blank, it may be a infinite blank, but blank symbol stands there. So we'll consider for language a to the power n, b to the power n goes with, it may be ab, it may be double a double b, it may be 3 times a 3 times b up to infinity. This is the possibility of language. Now with the first step of Turing machine, define logic. What is define logic? That means in the given tape it will start with blank. We'll consider this for the example. Here are 3 A's, then 3 B's, then there must be a blank symbol. Blank symbol for infinite number of blank symbols. Now what logic we are going to implement? For a single problem statement on Turing machine you can have different logics. Some of the student, I will say that the first A I will replace with X, then I will go ahead. Whenever B will come, I will replace with Y. As soon as Y occurs, I will come to left and I will check when the first X going to occur. Whenever first X will be there, I will go to the right side. I will implement here X, then go to right side till first B occur. Whenever first B occur, I will replace with Y, then I will move to the left side. I will come to the left side till first X is going to occur. Whenever first X is going to occur, I will go to the right side, replace A with X, then go to the right side. In the right side, I will wait for first B. First B, replace with Y, then come to left side till you have to come up to X. Whenever X will come, I am going to right side. Now in this case, what we are seeing? We are seeing y. Till now we are replacing a with x, a with x, a with x. Now what we are going to read? We are going to read with y. So as soon as y will come, I am going to stop here and go to next state. Once I will go to the next state, replace with y itself, replace with y itself, replace with y, till blank is not going to come. Till blank is not going to come. As soon as blank will come, blank replace with blank and stop here. Yes, then we are going to complete with our Turing machine example. We will explain you in brief once again, then we will draw how to draw the state transition diagram. See, this is the blank. Here we are going to start. What is the logic here? Whenever a is going to occur, I am going to replace with x. Fine, a is going to replace with x. Then I am going to right side. Where I have to stop? When I will read first b. That means I will read first a, replace with x, go to right side, read first b, replace with y. Whenever it will replace with y, it will come to left side. When it is going to stop? When it will occur with x. Whenever x will occur, it will go to the right side. Now in right side, whenever first a is going to occur, it will replace with x. Now it will move to the right side. It will wait till first b. This b will not be there because we have replaced with y. So that this b will be the first b. It will be replaced with y. As soon as replaced with y, come to left side. I will come to left side till first x is going to occur. When first x is going to occur, I will go to the right side and I will check whether there is a. Yes, there is a, so it will replace with x. Go to the right side till first b is going to occur. Both the b's will not be there because we already replaced with y. So this b will be the first b. Replace with y, go to the left side. When we have to stop? When we will get x. As soon as x, we are going to right side. Now in this case, we are not going to find any number of a's. So we have y. Y replace with y, go to right side. Y replace with y, go to right side. Y replace with y, go to right side. What is new symbol? Blank symbol. Whenever blank symbol is going to occur, we are going to stop here. Yes, this is the complete logic for the given problem statement. Yes, so after that, the next step is to draw the diagram. So for the diagram, we'll write here Q0 will be a state. Yes, what that range A is going to replace with x, is going to replace with x. What is action? I am going to right side. This is the way to write a transition in Turing machine. This is a state. A is the input symbol that I am going to replace with x and it is going to right side. Now it will be a Q1. When it will go to the right side, if I get any number of a's will be there, replace with a, go to the right side. A replace with a, go to the right side. When it will stop, whenever first b is going to occur, it will replace with y, go to left side. That means whenever first b will occur, it will replace, it will go back. So simultaneously we'll take example here. So blank we'll do here so you can understand. So first a replace with x, first a replace with x, go to right side. Any number of a will come, it will skip. Any number of a will come, it will skip. Skip means that will replace by same symbol. Both we are going to replace, skip. Now whenever first b is going to occur, I am replacing with y and I will come back. So my pointer will be in this state. That means in Q2 state, I have A replaced with A going to left side. We have to come A replaced with A going to left side. Whenever X is going to occur, X is replaced with X itself. Whenever X will occur, X will replace with X going to right side. Now in this case, X replaced with X going to right side. Now my pointer will be on this state. So on this state, A is going to replace with X, go to right. A is going to X, go to right. A, I am going to skip. Now check, the input is Y. For Y, what I am going to write? Y replace with Y, go to right side. Y replace with Y, go to right side. When it will stop? It will stop whenever first B will occur. Y replace with Y, first B occur, it will replace with Y. And it will go to left side. My pointer at this point. Now what is here? Y. We haven't written for Y. So please write here Y replace with Y, go to left side. It will come on this position. A replace with A, go to left. Now what I have found? I have found X. What is condition here? X replace with X, go to the right side. X replace with X, go to the right side. What I have found? A. Now A replace with X. So A replace with X. Then it will go ahead. So what I have found? Y replace with Y. Y replace with Y. What I am waiting for? I am waiting for first B. Whenever first B will occur, it will replace with Y. And it will move to the left side. On the left side, what I have found? Y. Fine. I don't have any A, so it will occur with all Y. And whenever first X will occur, what is the condition? X replace with X, go to the right side. X replace with X, go to the right side. On right side, what I have? Y. Have I written anything here for the Y? No. So we'll write here Y replace with Y, go to the right side. Yes, we'll write clearly Y replace with Y, go to the right side. That means Y replace with Y, go to the right side. So here will be a state Q3 state. We can check, we will have, there is a possibility that n number of Y will be there. N number of Y will be there. For n number of Y, we can have self loop that Y replace with Y, go to the right side. Y replace with Y, go to the right side. We will write here clearly. Y replace Y, go to the right side. So it will replace all Y's. It will replace all Y. So after all Y, what is there? It will occur with blank symbol. It will occur with blank symbol. If there is a self loop, that means n number of Y will be there. As soon as I will found with blank, blank replace with blank, go to the right side. And here is state Q4 or halt. Yes, here will be a state Q4 and halt. That is going to accept. Yes, in Turing machine, when we are going to stop? At the final state. As we know that in Turing machine we will have 7 tuples. All the tuples, the states, input symbol, the step symbol, delta, transitions, Q0, starting state, blank symbol, and F for the final state. We'll see a quick revision on the diagram and we'll understand about the language. For language, what I have? L equal to A to the power n, B to the power n. So we'll run our system for a smaller example. Let's take double A, double B. As we know that there is blank symbol for first and last. So we'll run, this is the starting state Q0, A replace with X. A replace with X, then go to the right side. What is here? A replace with A itself, A replace with A itself, go to the right side. That I am waiting for first B occur. Whenever first B occur, it will replace with Y. and go to the left side. So what I have found, A replaced with A itself. What I am waiting for? I am waiting for the first x is going to occur. Whenever first x is going to occur, that will be replaced with x itself. It will move to the right side. On right side, what I have? I have A. So A is replaced with x. Then I will go to the right side. On right side, what I have? Y. Y replaced with y itself. Then I will wait for first B. Whenever B occur, I am going to replace with y. As soon as it will replace with y, I am going to the left side. I am going to the left side. Whenever I am going to the left side, so what is the input? Input is x. For Q2 state, whenever x will occur, it will replace with x, move to the right side. That means in given problem statement, x replace with x, move to the right side. On the right side, what I have input? Y. For y, what is there? Y replace with y, go to the right side. Y replace with y, go to the right side. What I have? I have y. So here will be n number of y's. So y replace with y, go to the right side. On right side, what I have? I have blank. So blank replace with blank, go to the right side and stop here. You will have one more possibility, that blank replace with blank, and here is n. Capital N. Capital N stands for no moves. Have understood? So blank replace with blank, capital N, no moves. The state will be Q4 state. We are going to halt and accept. This is complete system. We have seen two examples. If there are 6 length, 3 and 3b are there, what will be happen? If there are 2a, 2b, what will be happen? So see slowly all the videos, then you will definitely understand. If you have any query, you can write me on my mail. So I will give you more example on Turing machine so that you can follow. Thank you for listening to my lecture. Please do subscribe my YouTube channel. I will update regularly with different gate concepts of different subjects. Thank you for the listening.